Welcome to The Explainer. So today, we're unpacking what is basically the ultimate double-edged sword of data storage, the Database Management System, or DBMS. We're going to really dig into exactly what makes these systems so incredibly powerful, but also, why they happen to carry some of the absolute heaviest burdens in the tech world.
Okay, let's dive right into this. Is centralizing your data actually worth the cost? Because let's face it, in the tech world, every single solution introduces a whole new set of headaches. What we're looking at here is the fundamental trade-off between keeping your storage nice and simple versus deploying this powerful, heavyweight database software to manage literally everything under one roof.
So here is our roadmap for today's explainer. First, escaping traditional file systems. Then, the power of centralization, followed by bulletproof data management. After that, we'll look at the heavy price tag, the risks of centralized systems, and finally, the final verdict.
All right, Section 1, escaping traditional file systems.
Think back to how a traditional file system actually works. The exact same piece of data might be duplicated across, a dozen different files. And that doesn't just waste storage space, it creates these massive conflicting pockets of information. Imagine an employee's address getting updated in the payroll file, but totally forgotten about in the HR file. That's a nightmare, right? A DBMS completely solves this by centralizing that data. It essentially ensures that an update made in one place is immediately reflected globally, which completely eliminates those incredibly frustrating data inconsistencies. Moving on to Section 2, the power of centralization.
Now, what's really interesting about this is how centralization directly elevates security. A DBMS provides these incredibly robust, centralized security frameworks. So instead of just crossing your fingers and hoping a file is password protected, system admins can restrict unauthorized access with serious, granular precision. We're talking about assigning specific roles, passwords, and permissions. For example, you can configure the system so an employee can log in and view their salary, but there is absolutely no way they can alter it.
And, this brilliantly illustrates another massive advantage, which is data independence. That's the architecture that completely separates the logical view of the data from its actual physical storage. And why does that matter? Well, this separation allows organizations to totally upgrade their hardware or shift their storage locations without ever needing to rewrite a single line of application code. The apps just keep humming along, completely unaware that the physical storage underneath them has shifted. It's brilliant. All right, Section 3. Bulletproof data management. Let's walk through this sequence. Say disaster strikes. Step 1, a massive hardware crash or a sudden power failure. Boom. In a basic file system, whatever you were working on, probably gone forever. But with a DBMS, Step 2 kicks right in. The transaction logs activate. The system actually relies on these logs to execute Step 3, which automatically recovers the data to its last stable state. This automated backup and recovery sequence literally prevents catastrophic, critical data loss when things go totally sideways. But to maintain that kind of fortress, you need strict rules at the gates, right? A DBMS guarantees data integrity and accuracy by enforcing these really strict validation rules and constraints. You can mandate unique IDs, valid date formats, or very specific number ranges, and the system will just automatically block any data entry that violates those strict rules. Basically, bad data simply cannot get in. And here's a real game changer from our source material. Multiple users or applications can access and modify the exact same database simultaneously without interfering with one another. This improved data sharing is a huge deal. It's made possible by strict concurrency control mechanisms, specifically locking. If two people try to edit the exact same record at the exact same millisecond, the system literally locks one out just long enough for the first transaction to finish. It keeps the whole shebang perfectly synchronized. But this power is definitely not free. As incredible as everything we've just discussed is, deploying a system of this magnitude comes with some profound complications. It's time to look at the other side of the sword. Section 4, the heavy price tag. Implementing a multi-user DBMS demands a staggering hardware footprint, and it goes way beyond just buying those pricey proprietary software licenses. Organizations have to invest in high-performance hardware, extensive RAM, blisteringly fast NVMe SSDs, and incredibly powerful processors. Why? Well, because a DBMS has massive structural overhead. It requires vast amounts of main memory and disk space just to manage its own complex operations, continuous system logging, indexes, and all those automated backups. And actually, here is a highly surprising fact. For very small datasets or super simple applications,
a DBMS can actually run slower than a basic flat file system. Seriously. The reason is that DBMS performance overhead. The software is continuously checking constraints, managing user permissions, and writing to transaction logs. So for a simple task, all that heavy lifting actually ends up creating a bottleneck.
And beyond the hardware, there is a massive human cost here. A DBMS is a highly sophisticated piece of software. Designing, implementing, and running it demands very specialized technical knowledge. Organizations have to hire skilled database administrators, DBAs, and they must constantly invest in continuous staff training just to keep the whole thing running smoothly.
This brings us to Section 5, Risks of Centralized Systems. The ultimate operational danger here is that massive number 1, the single point of failure. Centralizing all your organizational data into a single master system is incredibly efficient, sure, but if that core database becomes corrupted or suffers a catastrophic hardware failure or gets hit by malware, the impact is total. All dependent corporate operations can instantly grind to a dead halt. When the one master system goes down, everything goes down with it. Plus, keeping these systems alive is just tough. Moving legacy data into a new DBMS environment requires what are called ETL processes. Extract, transform, load. And this is a tedious, incredibly time-consuming process. On top of that, trying to keep up with rapid software update cycles often demands frequent, highly disruptive testing to ensure compatibility across your entire organization. Trust me, upgrades are rarely ever simple.